Hello students, today we solve one board question. The question is, a compound microscope consists of an objective lens of focal length 2.0 cm and an eyepiece of focal length 6.25 cm separated by a distance of 15 cm. How far from the objective lens should an object be placed in order to obtain the final image at the least distance of distinct vision, that is at 25 cm and at infinity? What is the magnifying power of the microscope in each case? This question is about optical instrument compound microscope. We know in compound microscope there are two convex lenses. One is known as the objective, which is closer to the object. Another one is known as the eyepiece, which is closer to our eye. Here the focal length of the objective is given, that is f0 equal to 2.0 cm, and focal length of eyepiece is given, that is fe equal to 6.25 cm, and these two lenses are separated by a distance of 15 cm, which is nothing but tube length, that is L equal to 15 cm. We need to find the object distance from the objective to get the final image at least distance, that is at 25 cm and at infinity position, and we need to find the magnifying power for the image formation at least distance and at infinity. We know the magnification of the compound microscope for the image formation at least distance is V0 divided by U0 into 1 plus D by Fe. Here V0 by U0 is the magnification of the objective and 1 plus D by Fe is the magnification of the eyepiece. So the magnification of the compound microscope is magnification of objective into magnification of eyepiece. This eyepiece is acting like a simple convex lens, and this is the magnification of the simple convex lens at least distance image formation. And the magnification of the compound microscope for the image formation at infinity distance is V by U0 into D by Fe. Here V by U0 is the magnification of objective lens, and D by Fe is the magnification of the eyepiece. This is the image formation of the compound microscope at infinity distance. Now we find the object distance from the objective for the image formation at the least distance. Here the image formation is least distance, that is V equal to 25 cm. This final image is formed by the eyepiece. So this eyepiece is forming the virtual image. For the virtual image, the image distance of the eyepiece is minus 25 cm according to the sign convention, and focal length of eyepiece is given, that is Fe equal to 6.25 cm. We need to find the UE we find according to the lens formula, that is 1 by F equal to 1 by V minus 1 by U. When we substitute the value, we get UE. Now we need to find the object distance of the objective to get the image at 25 cm. That is U0 we need to find. We find U0 by using the lens formula. For that we need V0 and F0. F0 is given in the question. We find V0 from the tube length, that is the distance between the two lenses, that is L equal to 15 cm given in the question. We know L equal to V0 plus UE. UE we found already. When we substitute, we get V0 equal to 10 cm. So when we substitute the known values, that is V0 and F0 in the lens formula, we get U0 equal to minus 2.5 cm. This is the object distance from the objective to get the image at the least distance 25 cm. Now what is the magnifying power of the compound microscope to get the image at the least distances? V0 by U0 into 1 plus D by Fe. When we substitute the values, we get the magnification of the magnifying power of the compound microscope is 20. Similarly, we find the object distance from the objective for the image formation at the infinity position. Here the final image is formed at infinity. Final image is formed by the eyepiece, and the image distance of the eyepiece is VE, which is equal to infinity. And when the image forms at infinity, the object is at focus. So the object distance of the eyepiece is FE, focal length. We know focal length is given in the question, that is FE equal to 6.25 cm, and from the tube length, when we substitute the focal length and L equal to 15 cm, we get V0. that is image distance of the objective. When we substitute all these values in the lens formula, we get u0, that is object distance from the objective for the image at infinity position, that is minus 2.6 centimeter. When we substitute all these values in the magnification formula, we get the magnifying power of the compound microscope for the image formation at infinity, that is equal to 13.5.